So, why did I choose to do my project on black holes? Well, I learned about them in high school physics, and since then I've really developed a keen interest in them. There is also a great deal of uncertainty and mystery with regards to them. Like, we recently just, photographed one, and they've been the subject of many scientific studies for several years, and they also hold answers as to how our universe works. One example that I'm going to talk about being Einstein's theory of relativity, and plus, the concept of a black hole is objectively fascinating. It really is. And then right here is a concept art for a picture of one. This isn't what the picture is in real life, but this is what we hypothesize one to look like. So as I said earlier, I'll talk about space-time and Einstein's theory of general relativity. Explains how objects in the universe interact with one another, relative to one another, I should say. These objects cause distortions in space-time. They cause ripples, which are gravitational waves. And so now we ask, what exactly is a black hole? It is an object of non-zero mass that has a relatively infinitesimal size, having a gravitational force so magnificent that photons of light can't even escape. So these are very, very, very powerful objects in our universe. Now, a Schwarzschild radius is the radius at which the escape velocity of a gravitational field supersedes that of the speed of light. And that leads me to the next part here, which is the event horizon, which is the theoretical radius from a singularity, which is the center of a black hole, to the edge of it, which is the point of no return. So what happens if an object comes too close to one? So from the outside, it would look like the person or object is falling. As the person falls deeper, object, that thing appears to freeze in time and would eventually disappear. Now, the person or object falling into the black hole would be spaghettified. In other words, that person or object would be stretched out, as differences in gravity are exponential with small distances, and as one would imagine, this would not be a good thing and something that no one should ever have to go through. Now, who exactly theorized black holes? Well, as I said earlier, Einstein's theory of relativity suggested that such objects exist, and Carl Schwarzschild did his research and hypothesized that there were collapsed stars or cosmic bodies that were not emitting any particles. And the term black hole was coined by John Wheeler in 1967. But then Stephen Hawking made substantial contributions to the science behind black holes, trying to explain as to how they disappear with time, as he came up with the concept of Hawking radiation, as electromagnetic particles are emitted from the event horizon and eventually will keep being emitted until the black hole becomes nothing. But this would take several billions of years, and is hypothesized to not even end until, like, a black hole's life would end well after everything else in the universe is gone. So now I'll talk about the Event Horizon Telescope. This was used to take the very first photograph of a black hole. This is a series of telescopes that utilize interferometry to create to create an image. A regular telescope would not be used to create a black hole image, but it would require the size of Earth, which obviously cannot happen. So a series of telescopes all around the world were set up to take small images of it that were eventually pieced together like a puzzle, and that series of telescopes simulates this. So now we'll talk about gravitational waves. Laser interferometer gravitational wave observatory, or LIGO, is one way that we can study gravitational waves. In fact, it was so popular it was featured on the third exam. But yeah, so it requires mirrors that are 4 kilometers apart, and in the middle there's a mirror or a beam splitter, and what happens is a laser is split, and it touches both of these mirrors and it comes back to one single point, and those cancel each other out. These lights, particles, are waves, and they have destructive interference. So when there's destructive interference, nothing shows up on the photodetector. But gravitational waves that come from outer space, millions and millions of light years away, can tweak the length of the light traveling, so as a result, it causes the photodetector to pick up differences, and one of the arm lengths are altered, resulting in this. And that's how we know that gravitational waves exist, even from cosmic bodies millions and millions of light years away. And it can be studied It can be used to discuss how two black holes interact with one another and how they interact. It's a very fascinating observation that astrophysicists have noticed. And yeah, these are my sources, and thank you.